Hi, Henk Hakkermans here, Supply Network Dynamics Chapter 5, Part 4, the case setting. The enigma of ASML. ASML is in many ways an enigma. It's very strange that a company which started off as being so very decentralized in the sense that it only manufactures a tiny bit of the total product was so successful, because often machine manufacturers are very much vertically integrated firms where all the different parts need to be done by the same company. Take even automobile manufacturers who outsource a lot, but the engines they often keep doing themselves. But ASML manufactures 3–5% of the total product. It's also very strange that if the bulk of the market is in the East, in China, Japan, Korea, and there's a lot of engineering and marketing, cloud and IT in the West, in the US, in the East and West Coast, that then in Europe there would be the hub of the lithography industry next to, well, as a spin-off of the former Philips Electronics. So I'll share a few slides with you to explain a bit more what ASML does. They are not a household name in the sense that you can buy the stuff in the supermarket. And all these slides are thanks to Mark Peels, who has long been head of central planning at ASML, even from 2000 onwards, I think, when I was working at that company. So here's a picture. Veldhoven is a small city next to Eindhoven, which is which is a small city in the Netherlands, which is a small country in Europe, but it's basically a spin-off of Philips Electronics. The story is that Philips Electronics had developed in research-wise, this machine that could manufacture chips, but why would they do that for their competitors? So the people at ASML were basically said to well, you take your business elsewhere, and a lot has resulted from that. What you see here is just the final manufacturing stage, the last few percent, and this big tower there, this big phallus, wasn't even there in 2002, 2003, and it contains the main central facilities next to the part here where most of the material coordination was done. Still not such a high building. So what? How does it work? Well, the chips that we talked about last chapter are manufactured in the machines that ASML makes, because with very strong doses of light, the patterns are created on silicium. So if you take in 2008 the entire market of electronic applications was 1300 billion worth. The chips inside those were, what is it, 20%, 15% of that, and as even a much smaller proportion of that is the machines that actually are used to make those chips. So it's a very small chunk of a very, very big market. The electronics sector is the biggest in the world nowadays. ASML started off very small. I still remember when I was working at Philips in the late 1980s that there were a few adventurous types who actually went to work for this spin-off, which was considered a very bad form, because hey, why would you leave this big electronics conglomerate that will take care of you from the cradle to the grave? They were tiny back then, and they're huge in 2008, and now they've even become bigger. Their market share is probably closer to 70–80% than anything else. And you can also see that here you see those market shares creeping up and up and up, and continues. And the basic way in which they do that is two ways. They are usually ahead in R&D, and they have the best machines also ready every time when the next upswing in the business comes. So they combine technology leadership with operational excellence. Very powerful combination. This is a wafer. They become bigger and bigger, but this is the silicon wafer, one that has been etched upon. You don't really etch, of course, but one where patterns of the light have taken away the top layer. And they keep doing that again and again and again. Through a mask like this, something like 70-80 different layers are etched on the printed circuit. Here you see the ID. You have a slice of silicium, you polish it, you take some bit off, put a photoresist coating on it, and there where the light shines through, the photoresist coating is removed. You then bake that, and you package it. And this part, all this part, is the semiconductor cycle. And you see only this part here, one cycle, is what ASML does. Now here you see under an electronic microscope a picture of these of such a pattern. So what you should realize is not just a 2D thing, two-dimensional, but really a 3D thing. There are like 70-80 different layers underneath all. So it's really a 3D picture. You can also have electronic currents flowing from top to bottom, not just from left to right. And it's really tiny stuff. And the performance of what they call the reticle, which is the part in which the wafer is held, is extremely fast. So from 0 to 100 km/h in 1.26 seconds, and as tight the precision is this of 2 747 jumbo jets flying the same route to accuracy of 0.001 millimeter. Crazy, of course, in the real world, but that's the kind of precision that you talk about in IC production, and it has only gone even more extreme since. We're ready to look at the 2000 demand bubble.